Look what happens if you put a piece of raw potato in hydrogen peroxide. Bubbles start to form. Why does this happen?
An enzyme is a specialized protein that catalyzes a chemical reaction. These enzymes are by default very slow, but the enzyme makes it go faster. The enzyme that is the subject of this video is catalase, which breaks down hydrogen peroxide into hydrogen and oxygen gas. It's found in raw potatoes. We investigated the effect of the environment on this enzyme. To test the reaction rate, we place a small circle of paper in a test tube with the enzyme solution, substrate solution, and water, and timing how long it takes for the paper to float to the top. The longer time it takes for the paper to reach the top means a lower reaction rate because less oxygen and hydrogen gas was produced. The materials, list, and procedure for this lab was sourced from Nelson Biology 12 and the page Assessment as Learning, Effect of the Environment on the Catalase Enzyme. First, some hypotheses. We will be testing the following variables in the environment: temperature, pH, enzyme concentration, and substrate concentration. Our first hypothesis is that if the solution is too hot or too cold, the enzyme will decrease in reaction rate. Our second hypothesis is that if the pH is not like that of a potato, so about 5 or 6, it will decrease in reaction rate. Our third hypothesis is that if the substrate concentration is increased, the enzyme will increase in reaction rate up to a point and then level off. And then part 4, fourth hypothesis, if the enzyme concentration is increased, the enzyme will increase in reaction rate. After a few hours of experimenting, we finally have our raw data. For part 1, we found that at 20 degrees Celsius, the time it took for the paper to float was the lowest at 23.1 seconds. It got slightly higher at 5 degrees for 32.97 seconds, and much higher at 80 degrees, taking 263.5 seconds. For part 2, we found that the relatively high and low pHs of 3 and 9 took less time for the paper to float than the baseline pH of 7. The test of pH of 3 only took 5.96 seconds, pH of 9 took 23.83 seconds, and a pH of 7 took 25.34 seconds. For part 3, we only had 3 data points. The final two, the low substrate concentration, did not have enough of a reaction to make the paper float. The high and low substrate concentrations took more time to work. The substrate concentration of 3% by volume took 37 seconds, 0.75% took 240 seconds, and 1.5% took 30 seconds. The data for part 4 is even more bleak, with only 2 data points. Any enzyme concentration less than 4 milliliters of solution, which is less than 1 milliliters of water, did not produce enough of a reaction for the paper to float. Confusingly, the test with the lower enzyme concentration had a shorter time, about 13.06 seconds compared to 21 seconds for 5 milliliters of solution. Remember that we wanted to see how the enzyme in the potatoes reacted to the various environments we put it through, and we made some predictions. Let's revisit these hypotheses to see if our data holds them up. To help us see the trends, I've graphed the data and added a trend line. For our first hypothesis, we expected that the hotter and colder the solution gets, the slower the reaction rate. This is held up by our graph here, where the time is higher the further away from 20 it gets. For our second hypothesis, we predicted that the more acidic and basic the solution gets, the slower the reaction rate. This is not at all what our data shows. In fact, our data says the opposite. giving us a trend where more acidic and more basic gives higher reaction rates, so a lower amount of time. For our third hypothesis, we predicted that with increased substrate concentration, the reaction rate will increase to a point and then level off. This seems to be held up by the data. Here it is slow, here it's faster, and these two are almost the same, illustrating the leveling off. And here we have no data at all because it took too long, illustrating a possibly steep curve. For our fourth hypothesis, we predicted that an increased enzyme concentration would increase the reaction rate. This hypothesis could be perceived as being held up if you treat the missing data here as though it was because it took too long. However, if you look at the data that we do have, there is a clear trend towards lower enzyme concentration and higher reaction rate. This is unexpected, and thus disproves the hypothesis. There are many possible errors and improvements we can make. First, we do not collect the data reliably. We got our paper circles from one of those three-hole punch things from the tray underneath. So there were many different kinds of paper with different densities in it, making the time vary wildly based on the type of paper we used. For the low enzyme and substrate concentrations, paper never floated, so data was never recorded for those parts of the experiment. We can improve that by allowing us to get data for the lower concentrations is by developing a more sensitive way to test for the reaction rate by using a lighter paper or some other method.